So we're going to start today. Today, by the way, we are doing area of polygons. And we're going to be looking at regular polygons and maybe even what are called some composite polygons or composite figures where we put two together. Or two or three, it could be more than one, more than two. Anyway, these first two questions that we're going to talk about are actually release questions from the state. They are in that test nav. You remember that's the computer program that you take the SOL on. And I've just kind of screenshotted them so we can look at them here together, okay? They're both multiple choice questions. So let's talk about strategies for multiple choice, by the way. What are some things you want to be able to do in a multiple choice question?
Process of elimination.
Eliminate some answers if you can. Would you agree? So answers that don't look right or don't make sense, I think would be some things we want to get rid of. I don't know if that's going to apply so much here, but in the second question for sure. Some other things I want to tell you is that on the SOL, almost always the figures are drawn to scale, okay? So if it doesn't look like an acute angle or if it looks like it might be longer, it probably is. Does that make sense? So you want to almost, and it will say figure not drawn to scale if it's not, but I think almost always they are drawn to scale, okay? That's good news. So I want you to look at this problem. What are some key words in the problem that you see? Regular, and it's a hexagon. Right? Do you agree? Both of those are keywords. All right. What does regular mean? Who remembers? We had some snow days. Do you remember what regular means?
That it's
What's true about the angles?
oh, they're all the same.
And this. Good. So the lengths of the sides are the same, and all the interior and exterior angles are the same. All right. How is that information, and we're going to use some of it, how is that information going to help us here? Well, I don't know. Well, all the outsides are 4, but what are we trying to find? So we're trying to find a length. Would you agree? We're trying to find this. Would you agree? All right. I'm going to give you a hint. If you look at this problem, to find lengths of sides, almost always, I shouldn't say always, often, how's that? You want to try to make a right triangle. And I don't see a right triangle in here quite yet, but I can make one. So let's do that, okay? If I draw in this guy right here, it's going to be perpendicular, which means I have a right triangle. And what do you think that little blue segment does to AC? It divides it in half, right? So now, what if I just look at this guy? So what if I just redrew that over here? And I want to find that side. Do you agree? That's the side I'm looking for? The left-hand side of the whole thing? Once I figure out x, what am I going to do for my answer, though? By how many? 2. Double it, right? All right, so I'll double my final answer. Great. I have a right triangle now. I know a lot about right triangles. How do I find the length of x? What are some options in right triangles? Pythagorean theorem is an option. Do I have enough information to use Pythagorean theorem? No. I need all the sides, don't I? I'm missing that right-hand side. I have no idea how long that is. What's something else? If I can't use Pythagorean theorem, what's the other thing I can use for right triangles? Sine and cosine, and that's what we're going to do. I'm going to use SOHCAHTOA, okay? Sine and cosine. But I need an angle to do that. Angles in a regular polygon. Think I could find one? You sure can. As a matter of fact, I can find that angle. I'm going to pause the recording for a minute, and I want you to think about, talk to your neighbor, think about how we can find the angle that I've labeled in blue. So think about this. that blue angle that I've labeled over here is the same blue angle in the it's half of the hexagon angle. Do you agree? So can I find angle E? If I find the measure of angle E and cut it in half, isn't that the blue angle I'm looking for? All right, so that's your hint. So keep working. I want you to tell me what the blue angle is. Yes. If we want to find angle E, we have two formulas we can use. We can find the outside angle first and subtract it from 180, or we can just use the sum and divide it by the total. It doesn't matter how you did it. I'm an outside-inside girl, so I'm going to do the outside first. The outside is simply 360, because it's always 360 for the sum, right? Divided by the number of sides, and so the outside angle is 60 degrees. Well, that's nice, but I want the inside angle, right? I want angle E. So I'm going to subtract that from 180, and so I get 120 in here. Well, that's great. How does that help me find the blue angle now? Not parallel. It's half. So all of angle B, angle ABC, is 120. Correct. The blue angle is half of that. So it's 60 degrees. Okay? All right. Any questions on how we found the angle? We had to use what we used last time, didn't we? Okay? Now we're going to use trig, because I need to find the length of x. Question, Derek.
I just lost where we got 6. Is it because they're hexagon?
Yes.
Because it's a hexagon.
Yes, sir.
Okay, good. So looking at my blue triangle, my right triangle that I've written off to the side, I want to use SOHCAHTOA. I want to use sine, cosine, or tangent. Let's label our sides. What's the x in terms of the angle? Opposite, adjacent? So that's opposite. And how about the 4? So which trig function? Sine, good. So let's see if we remember. The sine of what?
The sine of 60.
Of your angle is equal to x over 4. Great. And how do I solve it? Excellent. Multiply by 4. Double check on your calculator that you're in the right mode. What mode, Rodney, do we need to be in? Degree mode. And tell me what 4 times the sine of 60 is.
8.866.
Times 4, love.
3.4.
Let's do 2 decimal places. 3.4. Thank you. All right. Mode, and just make sure you're in degree. You don't want to be in radian. And remember, I can't tell you that on the day of the SOL, right? You have to check your mode on your own. Always want to double check your mode before you start. All right, so what's my answer? Well, let's look at the answer choices. Is X what I'm looking for, by the way? What? Read the question. What am I asked to find? AC, the whole thing. What is X?
X is 3.46.
I know that, but what is it in terms of AC? Isn't it half of it?
Yes.
So isn't this over here 3.46? But I want the whole thing.
9.2.
So multiply it by 2, right? So AC is 6.92. Okay. Look at my answer choices. I don't see 6.92. But can't I just go in my calculator and type them all in and see which one is the same as 6.92? Try it. I want to see everybody type in 4 radical 3 on their calculator. The answer choices are given to you in what's called radical form. I'm not trying to trick you. It's a different way to write the answer. That's all. So all you have to do is just type them into your calculator to see which one matches up. That's all. Okay? So the answer should be A here. All right. I thought this problem was kind of tough because it combined, first of all, you had to know to make the right triangle, right? So when in doubt, try to make one if you're stuck, okay? 2, you had to use the angles in a regular hexagon. You had to find that angle. And then you had to use trig. It combined worlds. SOL tends to do that. They tend to combine questions like that. So as we practice our SOL questions, which we're going to do every day from here until the SOL for the first part of class, we're going to be looking at how to combine these ideas. Okay? All right, I have one more question. I want you to think about this one. This is a composition. It's got a regular pentagon and a rectangle. And I want to make sure you can see the answer choices. That last one's 108, by the way, okay? So I'll pause the recording. I would like for you to look at how we can solve this for x. By the way, the last question was a side length. It was AC. It was a length of a side, right? What is x here? Is it a side? It's like an angle, right? So it's a little bit different. So we're looking for a degree measure this time. Okay, so I want you to think about this question. If you're stuck, look at your answer choices and eliminate anything that doesn't make sense. 108 makes no sense. I agree. It's too big, right? So you know what? Eliminate it. Don't guess that answer. I agree with you. All right? So when you're stuck, start with your answer choices. Which one doesn't make sense? So we've eliminated 108. I probably, since we know the picture's drawn to scale, wouldn't I also eliminate 72? Yeah. Probably. It looks too big too. All right? So if I'm guessing, maybe I would guess A, if I'm totally guessing. But I don't know. Could be 54, because it looks like it's, I don't know. 54 might be possible. Would you agree? But at least you have a 50-50 shot now, right? So eliminate where you can if you get stuck. What angle can I find in the picture because of what we did last class? Well, I can find the outside, and I can also find the interior. I couldn't. I'm going to highlight it with a color. Can't I find that angle? Isn't that the inside angle of a regular pentagon? Yes. Find it. So why do you think 108 was an answer choice to begin with? Because it's tricking you because it's the blue angle. Is 108 the blue angle? Yep. All right. So we know that there's a couple of different ways to find it. If you remember, when we did one inside angle, we found the outside one first. 360 divided by, in this case, 5, and you get 72. So if this is 72, what's the inside one? 108. So that's why the blue angle is 108. If I'm just looking now at the bottom, and I have this as 108 and these as x, what can I do to solve for x? Go ahead, Lucas.
You divide 72 between the two.
Yeah, well, but I'm not using the exterior angle. I'm using this idea here. So where did the 72 come from?
From
108 minus from 180. Then you get 72. Then you just divide by it. Then you divide by what's left. Okay? So your answer is 36. But we kind of could almost guess that just from looking at the picture, right? I'm not saying that you should guess. I'm saying that if you get stuck, that's not a bad way to go. All right? But mathematically, we're just using angles of a polygon. Right? Okay? Good. Let's go ahead now. Our notes today are on 8D. And it is area of polygons. Okay? And so we're going to look at the area. And what I'm going to give you or let you use for today is the formula sheet for the SOL. And it's important because some of the formulas are on this sheet and some of them are not. So it's kind of honestly, I'm not sure how they picked which formulas got on it and which ones didn't. I mean, I don't even know. I'll be honest with you. Your SOL is May 2nd. So in a month, when we get back from the spring break. We have basically the month of April to prepare. Wait, what? I don't, actually. You can sharpen that one, though. Okay, so we're going to talk about area of polygons, and this is the last section in Unit 8. Okay? And actually, we need it for Unit 9. Because in order to find the volume and the surface area of 3D figures, you have to know how to find the area of the base.
1/3.
If you look at your formula sheet for me, you will see a lot of 3D figures, and you'll also see some 2D figures. We understand what I mean when I say 3D versus 2D, right?
Yeah.
Okay. So if you look at the first two rows of your formula sheet, you see mostly two-dimensional figures, right? You see triangles, squares, rectangles, parallelograms, trapezoids. Do you see those things?
Yeah.
We have area formulas that are given to us for those, so that's nice. What we need to find is what if we have a picture where that formula is not on here, and that can happen. Like kites. Do you see kites on here?
No.
Do you see rhombuses on here?
No.
So we got some work to do, right? So let's think about how we're going to do this. So we have several examples. So we'll do examples 1 and 2 together here. But let's start with this example. So this will be example 1. And we are going to find the area of this particular rhombus. Okay? So how would I do this? So example 1, go ahead and write it down. I'll pause the recording while you draw your picture. Okay? And I'm giving you some important information off to the left-hand side.
You do the right.
Do you say ask your question again?
You do the right thing.
So, because it's a rhombus, these are right. Do you agree? Okay, that's important. So you definitely want to put that information in there. Good. As you're drawing this picture, I want you to use these numbers over here on the left-hand side, and I want you to label them on the picture. But I don't want you to use 10 and 8. I want you to use 5 and 4. How can I use 5 and 4? Because what do the diagonals do in any parallelogram? They bisect each other. So we're going to use that property here. All right, so what do you think that is going to help us find the area of this particular situation? So let's look. If I know that AC is 10, isn't this 5 and this 5?
Yeah.
Did you agree? Okay. And then what about BC? Wouldn't this be 4 and 4? Okay. So how is that information going to help us? Well, can I find the area of one of those inside triangles? How do I do that? Math. Of course we use math, but what? Be more specific. Yeah, we have a formula sheet in front of us. Use it. What's the area of a triangle? 1/2 base times height. Okay, so let's find the area of just that yellow one. 1/2 base times height. What's the base? If it's a right triangle, what's the base? 5. What's the height?
4.
Because it's a right triangle, right? All right, so what is the area of that? Let's not do a different way quite yet. But I promise you, I'll ask. Let me just finish this way and then we'll talk. There's multiple ways to do this. What's half of 20? 10. So the yellow triangle is 10. How can I find the area of all of the rhombus? What's true about all of those triangles on the inside of the rhombus? They're all the same. Aren't all the sides the same in a rhombus?
Yeah.
So all the triangles are the same on the inside. So to find the area of the rhombus, isn't it just 4 times 10? Or 40 centimeters squared. How do we feel about that? Just find one triangle, multiply it by 4. They're all the same. That's not bad, right? If you're given the diagonals, you got to break them in half. Done. Thank you. All right. Let's look at a kite. Can I find the area? This will be example example 2. Can I find the area of this kite? When you look at your purple formula sheet that you have in front of you, do you see a formula for kites?
No. I do not.
I do not. So I probably want to break it up into a triangle. Very good. Just like we did with the rhombus, right? We broke it into triangles. I happen to think that we can break it up into this triangle and this triangle.
Yes.
And add them together. What do you think about that? Will that work? I think it will. So let's find the area of the yellow triangle first. So we're going to do the yellow plus the blue. Would you agree? That's what we're doing. So we're going to have 1/2 base times height in each of those because they're both triangles. What's the base in the yellow triangle?
3.
No. The base is not 4. The base is 8. The whole yellow triangle, the whole bottom, the whole base. Isn't that 8?
Yes.
All right, so we have 8. And then what's the height
6.
of just the yellow triangle? It's just 3. Questions? You sure? You say you think okay with why 3? Just the height. How about in the blue triangle? What's the base of the blue one? It's also 8. Good. What's the height of the blue one? Just the blue one. Just this. Just the blue. It's hard to read, but it's a 6.
Oh,
Okay.
6.
So that's a 6. Are we okay with that?
Yep.
And then we're just going to add them together. So half of 24 is 12. Half of 48 is
24.
24. We're going to add them together, and we get 36 centimeters squared.
Wow.
All right, there's triangles. You got to know how to divide them up, okay? So in rhombuses, you just find the area of one triangle, and you got 4 of them. In a kite, you just divide it into top and the bottom and add them together. That's all. How about this guy?
What do you do that?
Radius?
Oh. It's an 8, so 8 is 8.
So be careful of what is labeled 8.
The radius.
This is example 3. Do polygons have radii?
Yes.
They do. It's kind of weird, because you think of a radius in a circle, don't you? So imagine if this was inside of a circle. What would the radius be from the center to the corner? So that's going to be the radius, okay? That's what we're going to label as 8. Well, that's nice, but that's not what I'm looking for. I am recording, my headset's just plugged in. Because it doesn't, the battery doesn't last very long. So I have to talk loud. Do I have a formula on my formula sheet for the area for a square? Yes. First of all, do I know why it's a square? It says regular quadrilateral. Isn't that a square? Regular, all the sides are the same?
That's square.
It's a square. So what's the S squared, right? So the area is S squared. S means just a side. Would you agree? So we have to find that. You with me? Or that. Right? Okay, so the two blue lines I drew are congruent. I agree. Can I call those X? Would that be okay with you?
Yes.
X and X. What if I just drew it over here on the side? Ooh, right triangle again. Another one. What's the length of the hypotenuse? It's not 8.
4.
Look at the picture.
Oh, it's 16.
That's right. How'd you get that?
Because that's the radius and then you got the whole thing.
Yeah, the radius is only halfway. the way down here, don't we? So that's another 8. So the whole hypotenuse is 16. So how do I find x? X is a side length. Look at the right triangle picture. At the beginning of class, we used trig. Do we have to use trig here? Huh? No. Do I have the side length? What was your first choice, Debbie? What did you say? Beginning of class. Pythagorean theorem. Can I use Pythagorean theorem here? Absolutely. That's what we're going to do. Let's find x. Okay? So we have x squared plus x squared is equal to 16 squared. Why is 16 by itself? Isn't that the hypotenuse? Isn't that the C? Okay. So let's solve it. How do I solve that x squared plus x squared? What is that? 2x squared. Isn't that like terms?
Yes.
So 2x squared is equal to 6. What is 16 squared, by the way? You guys have calculators. What's 16 squared? 256. Okay. How do I solve this for x? Divide by? Great. So what is 256 divided by 2?
128.
128. How do I solve for x?
Square root.
Good. So what's the square root of 128? 11.1? Oh, 11.3. And then I have to square that, because that's just a side length. I want the area. Don't I want the area of the square? Wasn't that whatever we just found squared? Isn't that just 128?
Yeah.
So the area is 128, and I'm not sure what units I use. Let's look. Centimeters. So our area is centimeters squared. So a couple things happen in that problem. Right? We have to know what a radius is. And we got to think about if that figure was inside of a circle, what would the radius be? So I just drew the circle there. The radius is always from the center out to a vertex. Right? And that's going to be important, what we're going to do here after lunch as well. Okay, so from the center out to the vertex, that's the radius. And then we're looking for triangles, aren't we? Happens to be a right triangle here, so we're in luck. We didn't have to use trig because we know that in a square the sides are the same. Okay. That's good. We have two more examples. Let's get through this one before lunch. After lunch is the harder example. It requires trig. Sure, we got to remember these things. They're not going away, right? They come into play all throughout. Trig next year is going to come into play for you guys if you go to Algebra 2. Mostly it goes in functions trig, but it's not going away. All right, so I need to tell you some information here. I need to tell you that this is a parallelogram. Okay? Do I have a formula on my formula sheet for the area of a parallelogram?
No.
Yes.
Look at the end.
Yes.
Yeah. On your formula sheet, you see the area of a parallelogram. Tell me what the formula says.
Area base times height.
It's just base times height? All right, perfect. Do I have that information on my picture?
Yeah.
I do.
13.
Yeah, it's just 13 times 6. What information on the picture is extra?
8.
8, I don't need it. It's just the base times the height. So the area of this guy is just 13 times 6.
Wow.
What would you get, Letley? 70?
78.
78. Good. And I'll just put units squared. I'm not sure what units are there. Centimeters, inches, whatever. So we just have to look at the picture and see what information we need. Okay? Important to remember that in any picture, heights are always perpendicular. So you want to look for that little perpendicular sign. Okay? That means height. All right? That's your altitude, if you remember, from triangles. Height. You're looking for that perpendicular. Bases are always the whole bottom. remember, sometimes they're turned on sides, so just be careful with that. All right? All right, what I'd like for you to do is write this is the last example, and we'll finish it up after lunch. So I want you to copy it down before lunch. Okay? Example 5, last example. Area of a regular hexagon. We can do it. All right, so the first thing I want us to do here is I want us to solve part number 1. I want us to find the missing angle measures. So let's do that. Let's look at angle 1 first. Look at angle 1.
Look at angle 1.
How do you think if it's regular, that's important information, the word regular, how can I find that angle? Look at the inside, all those angles together. All of them together, don't they make like kind of like a circle? So wouldn't that be 360? And so how would I find the measure of angle 1? Divided by 6, because there's 6 of those angles on the inside, right? Okay, that makes sense. So the measure of angle 1 is 360 divided by 6, which is 60. Does that make sense? Okay, good. How do I find the measure of angle 2? Look at where angle 2 is. Angle 2 is down here now. What is the relationship between angle 2 and angle 1? So if angle 1 is 60, what's the measure of this angle? 60. So what would angle 2 be? 30, because it'd be half of that. Would you agree? Good. So angle 2 is 30. That's awesome. All right, what do you think about angle 3? Think about where angle 3 is. Well, wouldn't it be half of this whole angle? Can you find the inside angle of a regular hexagon? I want you to do that. So go ahead and do that. We've done that multiple times at this point. I want you to find the inside angle of a regular hexagon. So what do? So you find the outside one first. And then I subtract that from 180. And you get, so 120 is the whole inside angle. What's angle 3 going to be? Half of that. The fact that these two are the same is a coincidence, right? So just be careful of that. Doesn't always happen that way. All right. So we got the angle measures. That's great. I want us to find the area of the hexagon. The angle measures are going to come into play because what if I found the area of one of those angles, or one of those triangles? How many of those triangles do I have in my picture? 6 of them. So isn't the area of this hexagon just 6 of the triangles? So what's the measure of the triangle? It's 1/2 base times height. Do you agree? What's the base? Look at the numbers that are given to us. It's 6. Because this is the base. Do you agree? This is also 6. If it's regular, the whole thing is 6. Is the height labeled? So I have to find that. I need to find the height. So what I'm going to do is I'm going to redraw the triangle down here, and I'm going to find that. Matter of fact, I'm actually going to label that as a 3. And this is a 3. Can I do that?
Yeah.
You should be writing this down because you're going to have to do this on your own here in a few minutes. Right, Derek? Let's go. Come on. How is this, ooh, I'm looking at a right triangle again, shocker. How is that going to help me find what I need? I want the height of that triangle. Can I do the Pythagorean theorem?
Yes.
I don't have the radius, Isn't the hypotenuse the radius of the hexagon? I don't have that, but I do have the angle. Don't I have angle 2? Isn't that 30 up here? So I'm going to use SOHCAHTOA. I'm going to use sine or cosine or tangent, one of those. Which one am I using? Very good. I'm going to use tangent. Because if I, first of all, do we understand where the 30 came from? It's angle 2. We found it to be 30. So I'm going to label opposite and adjacent. So it's the tangent of 30 is equal to 3 over h. And it's not the first time we've done this today. How do I solve this for h? How do I solve it for what I'm looking for? Multiply by h and then divide by tangent of 30. So h is equal to 3 divided by the tangent of 30. So type it on your calculator. What's h? What's the height of my picture? 0.17? I don't think so. Let me see how you typed it. Oh, yeah. No. So it's going to be, when you do this, you go alpha y equals, and you get a fraction, and you do 3 on the top, and then tangent of 30 on the bottom. Okay? Yeah. So 5.2?
Yes.
All right, good. So 5.2 is the height. So I'm going to put that in there. What's the area of the whole hexagon? 6 times 1/2 times 6 times 5.2.
31.2 divided by
I get a pretty big number.
15.6.
I get more than that. I was going to say, I think I get a little bit more than that. I got 93.6. Yeah. And because we're talking about centimeters, the area would be centimeters squared. Yeah, you got to multiply by another 6, right? So you found the area of just one of those triangles. Now you got to find all of them, the whole polygon. So basically, the thought is that if you can find a triangle, you can find the area, right? Sometimes when you have regular polygons, often you'll have to use trig, okay? So I have some problems I'd like us to work on. It's a combination of parallelograms and kites and rhombuses and regular quadrilateral or regular polygons. So let me find those. Here they are. I will tell you that problem number 6 is similar to the one that we're doing here. Okay, so similar. So if you were absent and you're listening to this recording, make sure that you pick up the area of polygons practice, because this will be due today. All right, so if you look at problem number, by the way, this says quiz on it. It's not a quiz, so don't panic, okay? It is going to go into the graded assignment, obviously, but it's not a quiz. If you look at problem number 1, that's a circle. Notice that on all of these, it's asking you for the formula and then what you did to solve it. Basically, I'm looking for the work in the formula part and then the answer in the area part. Does that make sense? So show me your work, what you're multiplying by, what you added or whatever, and we'll go from there. So number 1, we've done circumference and area of circles already. That's from the past. So you should be able to do both of those. But in problem number 1, what are you given the radius? Don't you need 2 pi r and pi r squared? So what's radius in number 1? 8. Good. So make sure you write that. R equals 8, because you're given the diameter. Luke, write R equals 8 on your paper for number 1. Okay? So problem number 2, what kind of a shape is that? No? It's a parallelogram. That's just base times height. That's pretty straightforward. Number 3 is your rhombus. Don't you agree? So look at your example for rhombus. I think that was example 1. right? Number 4. Ooh, we haven't talked about a trapezoid, have we? But the formula's on your formula sheet. Look at your 1/2. So can we talk about that one? When you, folks, when you have a trapezoid and you need to find the area, if you look at your formula sheet, this is what you see. Okay? When we talk about the height, remember that's the one that's perpendicular. The bases are the 2 parallel lines. Okay? So that's your formula for area of a trapezoid. So you have that on your formula sheet. And I think that, so if you look at problem number 4, let me give you a little hint on problem number 4, because it's not exactly straightforward. You have a trapezoid. If you look at this example on problem number 4, you don't have all the information you need. You have the 1/2, and you have the bases. What don't you have? A height. So you're going to have to solve to find that. Think about it. If I'm looking at this triangle, I have a right triangle. Do you agree? Right triangle. So let's go over here and draw it separate. I have 15 here. I need that. Do I have the bottom? What is it? What is the bottom of that triangle? Look at the picture. You can figure it out. Nope.
Oh, it's 6.
How'd you get that?
Because 6 minus 10.
Exactly. If you look at the top, and the top is 10, the bottom 16, doesn't this little guy here have to be 6? Because we have 6 and 10, because this is 10, that has to be 10. So they together would be 16. So can I use Pythagorean theorem now to find the height? All right. So those are the kind of things I want you to be thinking about as you're doing these problems, okay? Always, for you.